everyone, let's get this show on the road. Oh, we got some reminiscing about alcohol, do we? Oh, people just took in their attendance. So Tessa, you are Bushmills. Have I decided, have I persuaded you that a good Scottish single malt should be something you should try?
I'll give it a shot.
It's really good if you do it properly and don't overdo it. Okay, well, good morning, everyone. We are going to be essentially working on our last chapter. This is, excuse me, this is essentially where I was going to start today. But I'm going to give you a kind of overview of multivariate functions, and then we'll get started on this. So first thing I'm going to do is nip over and show you what I have in Canvas. Right, if you go over to Canvas and you click on our Zoom lessons, and you go down to, I believe I put it in week 10. There we go. Here is the intro to functions of several variables. So I've got a video there if you didn't know about it. Here it is. And that's basically going to cover 14.1. Now, if we move a little bit out of here, there are some software that will help you visualize and to work with 3D. For instance, if you hit GeoBra, this guy here, you can type in z equals x squared, take away y squared. And what you're looking at here, it's quite interesting. You see it's the surface, which is essentially what you get, right? So this is, oops, put the x squared in the wrong location. Well, it's correct, it is a surface, it's not the same surface. There we go. That's much better looking. There. Quite an interesting shape there, it's a saddle point. Right, so you get a surface. So here is things you can use to help you visualize them. If you also go back to Canvas, there is another thing called contour maps. And what contour maps do is that they allow you to, in 2 dimensions, which is what that is, visualize what a 3-dimensional surface would look like. And contour maps are used very often in multivariate geometry to visualize the shape. So each one of these lines represents all the points with the same Z value, right? The same height. And so when you look at this, can you see that it's like a hill here and like some kind of double hill here? Can you imagine what that shape would look like as a surface? And that's what you're doing here. You're visualizing a surface. Both those things, the 3D rotate thing does that job. Can you see contour maps give you the same information, but a little bit more 2-dimensional? And contour maps are very often helpful because if you see lines very close together, doesn't that mean that the surface is quite steep? And if there's bigger gaps between one line to the next, isn't that an indication of more shallow? So if you've been in the military and you've had to use, or you've done orienteering, I think contour maps are very helpful. Right? It's a way of visualizing. That's resources that you will use to help you with the first group of homework. Hopefully you've had a chance to look at these things. So let's look at a multivariate function. And this guy here, let's take that guy. Now, you can have this still written in 2 equivalent ways. And if I took this function or wrote it in that function, couldn't I go back to those software and actually visualize them as contour maps or just as surfaces in 3D? And so when you are talking about a multivariate function, you're talking about a function with at least 2 variables in it. So x and y are independent of each other, right? That can be x can be anything, y can be anything. That's basically what the coordinates on the floor would like. And the answer to this expression would be the height at that point. And that would be an example of such a function. So slightly out of order, let's talk about continuity. And let's talk about continuity first from the perspective that you already know, I hope. If I give you that fraction, would you agree that that function is continuous except at x equals 2? Would you agree there's a vertical asymptote problem? So continuity, right, is basically directly connected in many ways to another concept, which is called domain. Isn't a domain the usable values of x? So if I was saying to you, what's the domain of this function? Wouldn't you say it's everybody, but don't use 2, right? Don't use x equals 2. Now, in set builder notation, it would look something like that. In interval notation, it would be, oops, made a mess there, that says 2. It would look like that, right? So this is what the domain is. And this is also the values of x where the function is continuous, right? If you do multivariate functions, like this fella here, would you agree that this function has problems when x is equal to y? Would you agree that when x is equal to y, if you want to phrase it the other way, when y is equal to x, this has a problem? And so we would talk about this function and its continuity. And at the same time, we'd be talking about its domain. And we would say you can use any values of x and y you like, such that x does not equal y. And in this case, set builder notation is typically easier to describe the domain and the continuity. If I try to do this in terms of interval notation, can you trust me that it would look really weird and really ugly and not that clear? So typically when you talk about telling me the domain or the places where a function is continuous, the interval notation is going to be the correct way to do it. And you will simply have that as your template. And where the dotted lines go, that's where you will put any restrictions that you might get. So how about this function? If I asked you for the domain or where this function exists, would you agree that this function is okay, provided something is true? So let's do it in terms of what has to be true rather than what's not allowed to happen, right? This was x is not allowed to be y. What would the domain be for this function, and therefore where it's continuous?
Well, y would have to be smaller than 1/2 x.
Oh, you're trying to make it a little bit more detailed than it needs to be.
Do 2x squared minus y squared is greater or equal to 0. Oh, you already wrote that.
Agreed? Wouldn't that be a clip? Now, you could go into the nitty gritty and say x has to be less than 2y and things like that. But then if you're doing that, you have to introduce the fact that y could be negative as well as positive, and you'd have to stick absolute values around things. Would you agree that's just a cleaner way of saying what's going on or what needs to go on? Now,
Much rather say it that way because it's a lot easier.
It is a lot easier. Now, this guy looks almost identical, but it is slightly different. What would be the domain in a situation like this?
Wouldn't it be the same thing except for it's greater than 0 instead of greater than or equal?
Yep, that's all that matters. Now, when you have a function that looks really ugly, one of the tricks of the trade here is to know what to ignore. I'll give an example. Suppose this function had a plus x squared minus an x sine y attached to it. Wouldn't the only thing that mattered would still be this? wouldn't that have no effect on the domain, right? You could use any x you like and any y you like. So when you're looking for domain, i.e. When is a function continuous, shouldn't you only be looking at things that cause trouble and ignore things that don't matter, right? X cubed don't care. You can do anything you like with x cubed, right? X cubed y don't matter, right? 1 over xy matters, doesn't it? Because you can't have x as 0 and you can't have y as 0, right? Any questions about that? Are we good? So if I gave you a function and I said, can you tell me its domain? Can you tell me when it's continuous? Do you feel comfortable about how you would go about doing it? Okay. So let's focus on limits now. Before we start looking at the limits of a multivariate function, let me just remind you of limits. That we already know. Are we back in math 91? Are we back in math 151, I should say? Didn't we do some limit work? And from time to time, it's popped in and out again. For instance, didn't you have to do some limit work when you did improper integrals of type 1 and 2, right? That's about the only time I think you did it in Calc 2. But in Calc 1, wasn't there a fair amount of integrals, a fair amount of limit work that we did? And there was typically a couple of techniques that were kind of go-to techniques. Can anybody remember one of those techniques, what it was called?
Brute force.
Right, brute force. That would work. Give me another technique. Had a funny is, I believe the guy was Belgian, although he sounds French.
L'Hopital.
L'Hopital, right? Well, wouldn't L'Hopital probably come into effect with the more ugly ones, the weirder ones, right? Now
You
you
could
do
do the
brute,
divide by thing.
right? You could factor and cancel thing, right? So the bottom line is here we have lots of techniques that we've picked up from our Calc 1 world, right? For instance, this is not the only way to do this one, but I noticed that the top and bottom, or at least the bottom, can be factored. And when I cancel these out, you just basically get 1 over x plus 3, so the answer would be a 6. In this one here, I could do L'Hopital. If you do, you put a little L there. And in this case, differentiate, and then I can do it one more time with L'Hopital. Because sometimes in L'Hopital, you have to do things twice. And there's the answer, a half, right? Now, it is possible, isn't it, that when you do a limit, the answer is infinity, right? Because sometimes that's what you get. Sometimes brute force, you know, x squared over x, whatever, you get something like that. It doesn't matter what technique you use as long as it's valid. You can find limits. So let's show you then what it looks like in the multivariate world. Well, it's the limit as xy tends to the number 4,3. By the way, this is the version of question 1. And the expression that we're doing it to is this one. And what I'm suggesting that you do in a question is go for the obvious before you start making life awkward. Would you agree that this expression doesn't have anything particularly weird going on? And if you want to know the limit as xy becomes 4,3, would it seem reasonable you could just plug and chug? In other words, you can plug x as 4 and y is 3. And so play the obvious game first. 4 squared times 3 cubed, take away 8 lots of 3 squared. And that's what calculators are for. So let me just figure that guy out. So it's going to be 16 times 27. Take away 8 times 9. Let's try that again because that's clearly not right. 16 times 27. Take away 8 times 9. That's much better. So the answer would be 360. So I guess our first technique is basically plug and chug. You know you're not going to get many questions as easy as that, right? But just to show you that it is doable, right? Some questions and the limit is pretty much what you see is what you get. Question 2 is a plug and chug as well. Just doing a quick scan through. So is question 3. Here we go. So the first 3 questions, you can basically just get the answer by replacing the x with 4 and the y by 3 and getting the result. Because that's not going to last forever. So here's our first one that has a problem. Now, if I plug 9 and 9 in here, will you trust me you get 0 over 0, and therefore plug and chug ain't doing it, right? Brute force ain't doing it. I mean, you accept that it's 0 over 0, you're stuck. There is no L'Hopital, at least none that you know of, when there is 2 variables, x and y in this case. And the reason why there is no L'Hopital is, how do you differentiate that top line?
Will you
You see there's a
differentiate with regards to x and with regards to y?
Say it again, Tim?
You could differentiate it with regards to x and then with regards to y.
So you could do what? Implicit differentiation, I guess?
Yeah.
Yeah, if you did that, you'd be left with some dy by the x's floating around, in which case you'd be stuck. So L'Hopital is just not going to cut it. It's a pity. Would have been nice if we could have used it. Any suggestions?
Can you factor out an x squared minus y squared out of the top?
And if I do that, I'm left with the y take away x. Anything in the bottom? Anything I can do with x squared minus y squared?
You can do x minus y in parentheses squared, or separate them.
Yeah, it's a difference of 2 squares. Now, wouldn't that be the equivalent to this top process? Factoring, essentially. Now, some cancelling is going on here. While I'm writing this bit down, I want you to look at that cancelling, because it's not quite as clean as I'd like it to be, but you've got to live with what you've got. You are allowed to cancel y minus x and x minus y, right? You are allowed to cancel those. What happens when you do that? You have to compensate in a way.
You have to leave out a negative 1.
Okay, so what we're going to get then is that. Are you comfortable with where that negative came from? Now, this new simplified fraction, can't you plug and chug this one? So what do I get? I get negative 9 squared times 9 squared over 9 plus 9, which I'm now going to do on the calculator. 9 to the power of 4 is that guy, divided by 18, which is that guy, and stick a negative in front of it. And I guess to keep the math people happy, we don't like decimals, so we'll call it that. So one of the strategies for finding a limit is to factor as much as possible the numerator and denominator, hopefully to find a common factor that can cancel. Once you've got the simplified fraction, plug and chug. Right, so that would be a strategy that you could choose in some circumstances when you can't just plug the number in because you get that dreaded 0/0 issue. Let's try inversion equation 7. We're going to do the limit as xy becomes 0/0. And this is going to be 9x squared take away 3y squared over x squared plus y squared. Now this is a new question. We haven't seen one quite like this. Now, if you do the plug in, you get 0/0, right? So we're stuck. You might be able to try and factor that, and I know it does factor, but whatever it factors to has no effect on the bottom. So the factoring and cancelling technique that we used previously isn't going to help us there. So we are going to now create a totally new approach to this question. And this is nothing like you've done before. We're going to find a limit along the line x equals 0. And then we're going to find the limit along the line y equals 0. Now, what do I mean by along the line? Well, can you imagine this as a surface, which they all are? Aren't we trying to find out what the value of the function is at 0/0, right? That's essentially what we're doing. So we can travel along the x-axis, right, or along the y-axis, and that's essentially what these are doing. Now, let's start with the first one. If you make x equals 0, if you travel along the line x equals 0, this limit changes. It's no longer xy becomes 0. It's just the limit as y tends to 0. And 9x squared becomes 9 squared, take away 3y squared, over 0 squared plus y squared. Now, do you notice that the x's are being replaced by zeros and removed from here? Now, if I tidy this still up, it becomes the limit as y tends to 0 of negative 3y squared over y squared. Wouldn't the y's cancel here and the answer comes out as negative 3? So if I travel along the line x equals 0, the limit is the number negative 3. Now let's go along the line y equals 0. Well, in this case, all the y's disappear on you. So you get 9x squared, take away 3 squared, and x squared plus 0 squared. And so it now becomes the limit as x tends to 0 of 9x squared over x squared. And that is equal to 9. Now, how to interpret what's going on here? If you find this limit, assuming that x is 0 and then just make y become 0, the answer is the number negative 3. If you switch places, the answer becomes 9. Would you agree that these two numbers are not the same? What that is interpreted as is that this limit does not exist. If you put that expression into Desmos or one of the software, and you looked at what was happening at the origin, right, at x comma y being 0, you would find that at that point, the surface broke apart. And it can break apart in all sorts of ways. Can you imagine it could break apart as a vertical asymptote? It could also break apart where on one side it goes up to 9 and the other side it goes down to -3, right? There is no matched answer. Now, can we pretend a different story that was 5 and this was 5? Can you imagine that happened? Then what we could conclude is that the limit was 5. So if the answers disagree, or if one of them's infinite, that's just as good as disagreeing, right? Then we can put down here that the answer does not exist.
Do you use
Is-
that strategy if you were just like really lazy and didn't want to do like the work of simplifying,
Say
like
that.
the last type? So
Right.
could you use this strategy of like putting x equal to 0 and y equals to 0, like on the example of like number 4?
Well, you couldn't do it because the limit you're looking for is 9,9. So this strategy that I'm telling you about is only for a special situation where you're going 0, 0. It would be, well, I mean, if you did it over here, wouldn't you basically be finding what the limit would be at 0, 0? I could look at that one at 0, 0. What do you get? Oh God, you get 0 over 0. Ugh, you don't want to do that. That would be some kind of weird answer that, you know, we'd have to figure out how to do that in a different world. Let's try another one. This is question 8. Now you will recognize this special trick when the limit is 0, 0. If you don't see 0, 0, this is not the way to do it, right? You'll have to figure other ways to make it happen. So this is a 0, 0 again. It's xy to the 8 over x cubed plus y to the 12. Now, I kind of like that question, but can I hold that one for a thought? I will come back to it, but that one's got an interesting little thing that I don't want to talk about yet. Let's do 9, which is much more straightforward. Okay. Would you agree that if you plug in 0, 0, you get the dreaded indeterminate form, right? 0 over 0. So let's go along the path x equals 0. So it's going to be the limit as y tends to 0 of nothing. Oh, darn it. That one has the same issue. Okay. Then I will do that one. Well, let's do this one. If you do x equals 0, let me show you what the problem is. What do you get? Well, you get the limit as y tends to 0, no biggie here. X is nothing, y to the 0, so that's that. On this side, you get x cubed, which is 0, and then you get y to the 12. And can you see that there is a problem with that guy? So this question doesn't allow us to do the limit along x equals 0, y equals 0. Don't we need a number here to work with? Right? And 0 in the top over y squared is not the kind of number I want, right? I want something I can work with. So what do you do when the traveling along x equals 0, and can you trust me, y equals 0 also causes problems? When this fails, in other words, I don't know what the answer is using that technique, then you use this technique. We go along the line y equals mx. So I'm not going to go along the x-axis. I'm not going to go along the y-axis. I'm going to go along a y equals 2x kind of axis, right? Now, I could call that 2x if I wanted to, or 4x. It doesn't matter. I'm just going to call it mx, so it's nice and general. And let's show you what the problem is. Well, if you travel along this line, y equals mx, then you are going to change this into the limit as x tends to 0. You're going to have an x. Instead of the y, you're going to replace it by mx. And you're going to have an x, and instead of the y, you're going to have that guy. So far, so good. Now, multiply that out and combine it with this guy, you get m8 x to the 9. On the bottom, you get x cubed plus m x to the 12, right? So we are trying to find the limit as x tends to 0 of this fella. Okay, is there anything that we can do algebraically to make that a little bit prettier?
Factor the x's out of the bottom.
Okay, the best I can do here is an x cubed, so I'll do that. So far, so good. So what do we now have after cancelling an x cubed is that we have m to the 8 x to the 6 over 1 plus m to the 12 x to the 9. So far, so good. Think of m to the 8 and m to the 12 as just constants. Right, now, what's this thing going to look like when x goes 0 on you?
1 over 0. 0 over 1.
Well, I've had two answers. Would you agree that if you plug in 0, you get 0 over 1? Would you agree you can just plug in 0? So here's what the calculation looks like. And so the answer is 0. So we can now say that that limit is 0. So we didn't go along the line x equals 0, and we didn't go along the line y equals 0. We went along an arbitrary line called y equals mx. And the answer that we got here ends up being a number. And if this is a number, then the limit equals it. Can we pretend that we did a different question? And whatever the guy was, the answer we got was 1 over m, just for argument's sake, right? Can you imagine there might be an m left over, right? Now, could an m be 2? Could it be 3? Couldn't it be 42 million? Could be any number at all. What that tells us is that if the limit contains an m, and it can contain any kind of m you like, it could be m over m squared plus 1, I don't care. If it contains any kind of m. Your conclusion. What do you think the conclusion would be if I did this and I ended up with an m over m squared plus 1? Where m could be any number you like. What do you think we would conclude about the original question's limit?
Doesn't exist.
Correct. Because if I say, oh, I'll make m2, won't I get one answer? But if I make m22, won't I get a different answer? Can't you not have two different answers for a limit, right? There can only be one answer if the limit exists. So that's how you will interpret a does not exist. No. Okay, we got this guy here to worry about. Same situation. If I try to do along the zeros or the y equals zeros, can you trust me that we have big problems? it don't work. Why don't it work? Because I end up with zeros over zeros all over the place. So I'll travel along the line y equals mx. So it's now going to become the limit as x tends to 0, instead of this, is going to be x times mx over the square root of x squared plus mx squared. And so that becomes mx squared. And this fella is going to be x squared plus m squared, x squared. So far, so good. Right, now try and algebraically make this as pretty as you can. Is there anything you can do about that square root?
You can get rid of it and just put x plus mx.
So you can take out an x squared and then square root it. And that will end up looking like, whoops, will end up looking like that guy. Agreed? Write that again. I'll show you the line that I kind of did in my head. I'm pulling out an x squared. That in turn, because you can take a square root of both sides. We get that. If we cancel one of the x's, right, at this point here, can't I just do the brute force, make x 0 and see what we get? Well, I get m times 0 over the square root of 1 plus m squared times 0 squared. And the top is 0 and the bottom is 1, and we get 0. Which means this has a limit of 0. Any questions about this y equals mx technique for the
Yeah,
special?
actually.
Yes, what you got?
So we factored out the x squared. So
Mhm.
couldn't we just take it out
Oh.
of the bottom?
You're right, I missed that, didn't I? So it's still going to be 0 over 1 plus m squared, right? Which is still 0, would you agree? 0 over the square root of 1 plus m squared is still 0. Because
so the only time an m doesn't matter in the answer, when it's a 0 on top.
I don't have one handy, but I could do a question where the whole thing came out as 1. Right. Hard to imagine, but can you imagine we had a question that looked something like this? You know, just the way things work out. Right, can you imagine that's what we got, right? Just for argument's sake. Now, when we cancel this out, by that I mean cancel an x, I'm left with this guy. When you plug x equals 0 in here, can you see I could get the answer too? So, not sure if that answers your question, but essentially, if you're going to get a limit, 0 is a very common answer, right? That's very common, but it's not the only answer that could happen, right? Just putting you out there. Now, if I did a question, right, and it could happen, that the limit as x tends to 0 of whatever that thing is, ends up being 2m over m squared plus 1, right? That would be, does not exist. If when you're finished, the answer has any kind of m in it, anywhere, right? It hasn't been killed off by x times m gets you 0, right? That means does not exist. If this happens, the limit exists. And the limit will be whatever that number happens to come out as. That makes sense. Okay, any other questions? Last name and bye-bye, and I will see you tomorrow where we will hopefully finish this off.
One homework.
Say again?
I had a quick question about the 14-1 homework.
Sure, what you got for me?
Just to put the answer in WebAssign. I don't know how to make the little, well, I don't know, are we supposed to put it in the type of form where it's got the squiggly line such that blah, blah, blah form?
Wish I knew what the squiggly line
Sorry.
blah, blah, blah form
I
was.
know, sorry, you just said it. Let me look at the set builder notation.
Okay, so
I don't know how to
curly
make a long
brackets,
line.
that line there? Right, let me
Yeah,
see, let me see what WebAssign expects from you, because I have seen textbooks where they use a colon.
okay.
Right, I'm not saying that's what it is, but I have seen that in a textbook. So I'm just kicking into 14.1 if you have the
Okay.
patience to wait, we shall see what it is. Well, which number was that again? Off the top
Number
of your
4.
Number 4, so it's pretty early on. So there shouldn't be too many weird stuff happening yet. Almost there. Just finding 163, gotcha. 14.1. Click on it. Oh, it's a short one. Find a, I'm looking at find the sketch of the domain of the function. Okay. Is that the one?
I think it asks for the domain.
It does. I'm not sure I'm at the right question. Did you say question 4?
Yeah, I thought so on 14.1.
Okay, question, I'll show you what question looks like and you can tell me, no, I mean the one above it or something. That might make sense. Okay, so we got this guy. Okay,
Okay.
does that look like the one you're talking about?
Yeah.
Okay, so if they, sketch the domain. Okay, so it evidently the domain is going to be one of these pictures. So you don't need the squiggly stuff to sketch the domain. You only need to know what it is. Would you agree that that guy there has to be greater than 0 for a log function to work?
Yeah.
Right, so I'm writing that guy down. So it's 36. Oops, I clicked on something by mistake. 36, take away 4x squared, take away 9y squared, take away z squared has to be greater than 0. So let me rearrange that and then we'll look at what the visual of this would be. This is actually a 4th dimensional function. So I won't need that notation right now. If I was going to use that vertical thing, you don't actually need to, you only need to pick a picture. But from this one here, a rearrangement of that is at 4x squared minus 9y squared and z squared. So what's that going to be? Make them all pluses. Those guys have to be less than 36. This guy is an ellipsoid and there's the 36. So I just need to find something that looks like an ellipsoid and we are good to go. And the only one that looks like ellipsoid is the first picture. So out of the 4 pictures, it would be that one in my story.
Okay. I actually got that part right, where I picked the sketch, but I swear my question asked me to type out the domain and I just wasn't sure. I tried to do it, but I couldn't get Cengage to accept my answer.
Right. I'm going to see if I can find a find a domain thing and see what we've got. Right, they have that vertical line. So it does exist. So let's see if we can make that happen. If I click on this, where would it be hiding? Okay. Here we go. what I'm trying to do is find that vertical line, right? So
Yeah.
first place I'm going to look is in one of these things. It's going to, that's what the answer is going to look like. You can see it down here. So it's going to be curly brackets. You're going to put in X comma Y comma Z, which is the easy bit. Right, and then we need to do that vertical line. So let's see, it's none of those guys. Not that guy. Definitely not that guy. Not him. Interesting. Oh, I wonder if you need to click on that for the curly brackets, but that doesn't seem to be a big issue. Okay, since they don't have it, I believe it's try Shift 1. No. Shift Control 1. No. Shift \. Gotcha. There we go. On your keyboard.
That's an absolute value, I think.
Well, it definitely gave the vertical line that I was looking for. So what would the domain of this be? It would be Z, it would be, well, actually the domain of this one is everybody, as long as this is greater than 0. So Z take away, I'll see if it will accept this, the square root. Do we have a square root? Square root. X squared plus Y squared.
Are you here, Christian?
Yeah, I'm trying to figure it out myself.
Did you saw that problem, number 4? Does it ask?
No.
Oh,
That's
okay.
that's why I'm trying to figure it out.
Oh, okay.
Okay, that's what it would look like. But you're right, that isn't taking it. So let me copy all of this and work on plan B. I found where the key is, but it interprets that. So I'm going to do a colon, which is an alternate notation, and try that. Okay. Oh, I can't check answers. Do you want to check with a colon?
Yeah, I'll try it later. I'm actually at work, so
Oh, okay.
I gotta get
The key is Shift to the right. If you find the enter button, it's one to the left of it.
I found an easier way. I know it may or may not work. If you control copy the little 1 bar and then put it down and then control V for paste, it'll work right through. I just don't know if it'll be correct. Oh, I guess not. Never mind.
Now, here's something. When I put the colon in, it didn't tell me that it was not acceptable.
Oh, yeah.
So you may want to try the colon. It won't do the vertical line. It makes it absolute value when you try and do it. So the alternate is that one. So that's going to be our workaround is, I think, to put in a colon and check it out. Hopefully it works. If it doesn't, then I'll go hunting for another way to make it happen. The only 2 notations that I know are that. Now it says as a comma separated list of inequalities. It simply might just be, now I'm thinking about it, they may just want you to write down nothing except that. And if there was another one, let's just say for argument's sake that for some other reason that would be a comma separated list. I'm putting in little gaps there to make it more obvious, right? So they may not need to set built-in notation. There's another workaround. So there's 2 ways my brain is thinking about how to get around the issue. One is don't do the curly brackets or anything, just put what the condition is. If there's 2 conditions, put a comma between the 2.